So far we have learned about the two models that are part of any SCR models, the detection model and the density model. We've learned the concepts behind estimating the detection probabilities in Chapter 1 and behind estimating abundance and density in Chapter 2. In this lecture we'll learn about building capture histories, which is one of the necessary steps for fitting SCR models. Remember this slide from Chapter 2 on abundance estimation? This is where you first encountered the term capture history, and we learned that this is one of the three required inputs for the model fitting function. So in this lecture, we'll build two capture histories, one for a 2-detector example and one for a 16-detector example. So let's start with the 2-detector example. So we'll learn best what capture histories are by constructing them ourselves. And in the next lecture, we'll find out that R can actually do this for us, provided we give it the right information. So let's start with this example. This is the same example as we've already talked about in Chapter 1, Part 2, with the 10 animals and 2 detectors. And we'll now build a capture history for this. All we really need to know to do this is contained in this image, which simply indicates which animal was detected by which detector. As a side note, you might wonder why we call this a capture history when nothing actually gets captured. So this is jargon which originates from the first studies when these methods were developed, where animals actually had to be captured to be marked. In the meantime, new versions of these methods have been developed, like these here, where capturing is no longer necessary. All you need to do is to detect the animal and match your detections across detectors. What I mean with with the word matching, is that you need to be able to tell if an animal detected by a detector was also detected by another detector. So in this example, we have 2 detectors, which each detected and marked animals. We'll use this information now from this image and create a capture history for this sampling occasion. We start out by giving each animal an ID. There were 10 animals, so G1 to G10. Hereby, it is not important what sequence you name your animals in, only that you can uniquely identify them and are able to match them between detectors. Before you start wondering now how you can uniquely identify gibbons or gibbon groups, we'll talk about this in Chapter 6. Next, we start a table which will serve as our capture history. What we created here is a simple table with a record for each animal. There were 10 animals detected in total and a column for each detector, so 2 detectors in total. We will now check which animal was detected by which detector for each animal detector combination. If an animal was detected by a detector, we put a 1 in the table in the corresponding location. If it was not detected by a detector, we put a 0. And this is what it looks like filled in. For example, G1 was detected by detector 1 and not by detector 2. G2 was detected by detector 1 and 2, and G3 was also detected by both, and so on. Let's try a more complicated example. This example was also part of Lecture 3, Part 2. Part 2 lecture of Chapter 1. In this example, we have 71 detected animals that were detected by 1 or more detectors, with 101 detections overall. We can emphasize which detector detected which animals by using different colors for the detections of each detector. This will make it easier for us to determine which detector detected which animal. We'll now set up the capture history for this example. We have a table that looks similar to the previous capture history, with rows, which are the individuals, and columns, which are the detectors, except now each animal will have 16 entries in its capture history, which can be ones or zeros, of course. Animal G1, for example, was detected by detectors 1 and 2 and not by any other detector, so it gets 2 ones in the correct locations and otherwise zeros. Animal 2 was only detected by detector 2. Animal G3 was detected by detectors 10 and 11, and so on. Lastly, we do this for all 71 animals. The last animal, shown again here, was detected by detector 5 only. I couldn't fit in 71 rows, so 1 row for each animal here, of course, but the real capture history contains 71 rows. But actually, I should correct this, because in a real survey, we most likely don't know where the animals are. So all we would observe and need to know actually looks like this. We would only know that detectors 1 and 2 detected G1 and none of the other detectors. Only detector 2 detected G2, and only detectors 10 and 11 detected G3, and only detector 5 detected G71. At this point, you might ask yourself, what happened to this talk about distances to the animals and how detection probabilities declined with distance, and then we don't actually use the distances to these animals. In fact, we don't usually know the distances to the locations of the animals or groups when fitting SCR models. The information is actually in the capture history. The fact that detectors 1 and 2 detected G1 and none of the others tells me that this animal must have been close to these detectors and further from the others. That is all the information SCR needs to know in order to fit the model. So here are some key points from this. We use the information from the detections, which animal was detected by which detector, to build the capture history for the sampling occasion. We do not need to know the distance to the animals for building the capture histories. And in the next lecture, we are going to use these capture histories and in combination with the mask and the detector information, use these to fit a model in SCR.